I thought I'd do one more. We're doing 1C because it's another short one. And this is Math is for Teachers. This is Dr. Schulman here, and I'm sharing my screen. Hopefully this stuff is clear for you. If it's not, guess what? I'll do my best and reach out. So we're doing the strategies for mental math, estimation, and rounding, and know when to use the strategies. So let's see what we got. So I'm in Delta Math right here. We're up to 1C, estimation, mental math rounding. All right, you'll see this one when I edit it. Again, we got a shorty. That's all we're doing. Nice and simple. Mental math, like are we counting with our fingers or we're estimating? What do I always show my students? So if I've got 147 plus 201, I'm just telling them, all right, if this is like 150 plus 200. Just so then they get a sense of what it actually is. So your answer should be around 350. That's what I always do. All right. So if a student tells me they've got, I don't know, 23 over, I don't know, like 108, right? This is the fraction they're working with. Well, I have them draw a picture. This is 100, and we're really just looking at a quarter. Have them estimate all the time. It's going to give them a sense, have them estimate, have them draw pictures. It's just going to make their life so much easier. So these are just a bunch of mental math things as well as estimating that we can do. One of the biggest things I have is I say, draw me an angle that's 42 degrees. And then I have them draw it and then see how close they are to 42. If we know 90 looks like this, 42 halfway is 45, so it's got to be a little bit less. Mine's probably off. I also have them do stuff like this, like draw 3 centimeters. I think this is about, or 3.2 centimeters, right? I have them actually draw the line, take a ruler out. Oh, I can see my thing here. We want 42 degrees. Can I spin this thing? Come on, be my friend, ruler. I said 42, but I wanted the other direction. So 42, the other side should also give me 42. So here we go. Let's drag it. I was pretty off the first time, still off the second time. That's how close I was. So that's just some things you can definitely do for your students. Let's get out of here, ruler. All right, so that's something really useful for them. All right, let's do some of these. Combining positive and negative numbers. What can we do? Two minuses make a plus. Two minuses make a plus. Negative 10 plus 2 plus 8 is 2. Oh, it's negative 2. So this is going to be a negative 1. This is positive 4. This is a positive 1. This is a positive 12. This is a negative 8. This is a negative 16. This is a negative 11. This is a positive 15. This is a positive 12. Last one is a positive 4. And there's my best time. Cool. All right, let's do some more of these. Perfect squares. All right, 7 squared. So 7 times 7. So you can have your students literally draw this 7 times 7. And 1, 2, 3, 4, 5, 6. So that makes 7. 1, 2, 3, 4, 5, 6. So that makes 7. And count them all, but you will see it is 49. That's what this means. That's 121. This is 100. This is 9. This is 16. A lot of students will multiply this. That's why that choice is here, but you should know better. That's 256. Oh, it's 196. Oh, man. All right. 225, 16. It's 196. It's 196. I'm not going to forget. 81, 64, 36, 49, 81, and finally 16. Let's stop it right there. And there's my time. All right, let's do multiplying, dividing integers. This is a -8. So you can have your students practice by making tables. One of the most common ways that I've had my students do this, I have them make this giant grid on their desk that's 1 through 20 in one way, 0 through 20, and then 0 through 20. And I have them have this on their desk and they have to fill out every single one. And that really keeps them from forgetting. But whatever works for you, you know? And the last, oh, I was already done. Cool. All right, let's see what else we have. Now here's some more mental math, squares and square roots. So the same way that we have this, so if we have the chart, that's a 3 by 3, and we know this is 9 boxes. If I take the square root, this is what it means. One side of a square is going to be 3. So that's 8, 81, 36, 81, 6, 100, 36, 7, 10, and 64. And square root of 0, 0. I just did an extra one for fun. All right, so what do I do for students? I always have them estimate. So let's say we have square root of 10. I have them basically, well, let's do imperfect. So let's do square root of 20. I have them think about the 2 square roots that's in between. So this is between 16 and 25. We're kind of right in the middle, right? So it's going to be a 4, square root of 16 is 4, square root of 25 is 5. So it's going to be about like 4.4 or 4.5. Let's see how close we were. 20 square root, 4.47. I said between 4.4 and 4.5. The other way you can have them do this is take the square root. We know this is square root of 4, square root of 5. So this is 2 root 5. This is simplifying, and that's estimating. All right, here we go. Some more perfect squares. 18 times 18. We're not going to go this high. I'm going to take these out, so you don't have to do these. I only really do 1 through 20 with my students. I never really go up to 30. All right, so here we go. Some GCFs, greatest common factors. Let's try these. These should be tough. 40 and 25. I'm going with 5. 27, 39. I'm going with 3. 28 and 9. I am going with 1. Nice. 26 and 50. I am going with 2. 40 and 10. I'm going with 10. 8 and 49. Ooh. I'm going with 1. So if they don't have a factor, that's fine. 14 and 36. I'm going with 2. 32 and 44. Is 4 going to 30, 44? 30? Yeah. All right, 36 and 6, that's a 6. 18 and 32, that's going to be a 3, because 1 plus 8 is 9, and 3 plus 2 is 5. Oh, 3 doesn't go in, it's 2. And 20 and 12, the final one, I'm going with 4. Nice. Oh, I did an extra one. And let's do some least common multiples before we get to rounding. So for greatest common factors, right? When you have things like greatest common factors, I don't know why it's not letting me click. So when we have stuff like GCF, so how was I doing those? In my head, and you can teach students how to do this, greatest common factors, it was 12 and it was 40, right? That was one of them. I did 1 times 12, 2 times 6, and 3 times 4. This is 1 times 40, 2 times 10, 4 times 5. Sorry, not 4 times 5, 4 times 10. Oh, sorry. and 5 times 8. So I saw 4 was the greatest number that matched. Now for this least common multiple, I have 12 and 8. I just have to see when they match. So 12, 24, 36, 48, 8, 16, 20. Oh, we're already there. It's 24. That's the least number where they match. 6 and 11, I'm going 66. 16 and 4, I'm going with 16. 4 and 16, I'm going with 16. 2 and 16, going with 16. 8 and 7, I'm going 56. It lets me. 6 and 12 is 12. 6 and 10 is not 20. It's 30. 7 and 12 is 12, 24, 36, 48. I'm going 84. I think it's 84. Nice. 7, 8 is 56. 9 and 4. Nope. Nope. 36. I already beat it. Okay, well, whatever. There we go. So try some practice with it. It'll be fun. All right, we get to round. All right. Oh, wait, I want the problem. Show question. Here we go. 8.54 to the nearest whole number. That's 9. Oh, we did these already. I just thought I'd show you again. To the nearest hundredth is here. So that's 0.77. Nice. Circumference. All right, we finally get a geometry problem just for the fun of it. So I have a circle. They tell me that the diameter is 12. So if they want the circumference is pi times the diameter. Diameter is 12, and this is 3.14, right? So if I do 12 times, well, I can do it this way, right? It's going to look like this, but I want to write it this way. 314 times 12. 2 times 4 is 8. 2 times 1 is 2. 2 times 3 is 6. That's 0, 4, 1, 3. So I have 8, 8, 7, 3. Now, all we have to do is look at this thing, right? All we have to do is look at this thing. 3788, and we have 2 decimals. So here we go, 1, 2 decimals. 37.88. They want it to the nearest 10th, so that's this place. The 8 is bigger than 5, so it's 37.9. That's the answer. Nice. Okay. Oh, they wanted the radius 2 pi r. I just did pi times diameter. That's fine. 37.888. Did I get it wrong? What? 12 times pi is 3.14. Oh, they actually want to use all of pi? Oh, you gotta be. Oh, they said I did the 100th? No, that's the 10th, 30. All right, let's see. I don't like it. All right, so 3.14 times 3.14 times 12. 37.68. Oh, that is a 6. What a stupid mistake. So it's 37.7. Bastards. Sorry. I'll do one more. The diameter of the circle is 5. Just because we're just about at the end of this one. So they can write it as 2 pi r, but I just write it as pi times diameter if they gave me a diameter. So it's 314 times 5, and then we're just going to move it twice at the end. So that's 0, 2, 7, and 15. It's 15.70. They want it to the nearest 10th, 15.7. I don't like when I make a silly mistake, but that's what precision comes into play. All right, rounding numbers, level 2, 10 thousandths. Ooh. All right. 911.36998.464. So this is the tens place, this is the hundreds, this is the thousands, and this is the 10,000s. So this number is bigger than 5. So this goes to 0, which makes this go to 0, which makes this go to 7. That was hard. So it's 911.3700000. Tens, hundreds, thousands, 10,000s. That was a tough one. So try these yourself. Ta-da! And if they were too hard for you, oh, we got a Pythagorean theorem rounding one. It loads. Okay, myself, I'll go to the right this time. Find the length of the third side. If necessary, round to the nearest tenth. Okay, so basically, Pythagorean theorem says a squared plus b squared equals c squared. So this one just has to be the biggest one. But why does this work? Why does this work for students? So this is a times a, however many spaces that is. This is b times b. I use a different color. Make this green. So if I take all of these cubes, squares, and all of these squares, and I put them together, I should get this one. I should get the c's. This is the theorem of Pythagoras. All these little squares put together should make up them. So we get to round to the nearest tenth. So here we go. I like drawing it right side up. So that's 24. This is your blank. There's your 30. So a squared plus b squared equals c squared. So it's 24 squared plus I have no idea squared equals 30 squared. Well, 30 squared is 900. 24 times 24. I would probably round this to 25 to make my life easy, right? That's okay. 4 times 2 is 8. That's 96. That's 0. That is 8. And that is 4. So 6, 7, 576. So what do we have to do? We have to minus 576 to both sides. That's what x squared equals. So that's 8. 9, 10. So what do we got? We got a 4. We got a 2. We got a 324. Square root of 324. Doesn't look like it's going to be a pretty number. 324 square root. Oh, it's 18? Man, that's annoying. So I usually do 1 through 20, but I forgot 18 like a fool. That's the answer. So we didn't have to round. After all that, right? Ta-da! Cool. All right, so here we go. Here's another rounding one. We got coordinate distance, so another Pythagorean theorem. We got, and then we get some estimations. All right, so graph the right triangle. Okay. So we have click twice to draw a line. Okay. They're showing you that this is another way we can do it. You may now answer the questions below. Okay, so whenever they just give me points for Pythagorean theorem, so if they say, what is the distance between 8, -8, and 3, 4, you can use this crazy formula, x1 minus x2 squared plus y1 minus y2, right? There's the distance formula, but this is just Pythagoras. Because if I take the distance between, so this is the point 8, -8, and here's 3, 4. So if I want to make the triangle, I just have to figure out this distance and this distance. So if I'm going from what? Ready? 4. So the first one is, sorry. So if I'm going from 8 to 3, right? That's this is the x distance. From 8 to 3, how far do we go is 5. Ta-da! And then if I do this distance from -8 to 4, how far do we walk? -8, and then we go 4 up. That's going to be 12. And we're squaring them because if it's negative, it'll still become positive. We square them because we're figuring out these distances, so squaring them actually gets that away. So this is 25 plus 144. Or you can do it. It's the same thing as thinking a squared plus b squared equals c squared. And then, so this is 9, 169. So this is 13. This is a Pythagorean triple, 5, 12, 13. There's 5, there's 12, and our distance, we're going with 13. Let's see. We did it! Ta-da! All right, the last one. Now we get to do some more estimation. I like this. Ooh, this one looks hard. Estimate the length of A as a percentage of the line B. Estimate the length of A with the percentage of line B. Okay, so I think A is about half. I think it's about 50%. Estimate the percentage of A as line B. I'm going with 50%. I don't know why. It just seems like it's 50% to me. Oh, beautiful. It's halfway. I love my estimation. Let's try another one. That was hard. All right. I'm going 80%. Let's see if that's right. 80%. Let's go with it. Oh, I was off by 6. Oh my God. 74%. Oh, let's do another one. All right. 1, 2, 3, 4, 5. 20%? Could you be 20%? Yes, 17%. I like it. Let's try one more. Ooh, this is about half. I'm gonna go with 60%. 62%. What? That was magical. It was a perfect match. All right, let's try another one. All right, so when they're talking angle bisector, okay, so this word angle means two rays with a common endpoint, and we measure it by the distance. We can name this YXW, so we can call this YXW. We can call this angle WXY. It has to be in the order. We can't call it XYW, then it'd be different, or we can just call it angle X. So bisect, think binoculars, bicycle. Bisect means to cut, in sect means to cut. So we want to cut it into 2 equal parts. So all we have to do is try our best to cut this thing. Oh, come on. Okay. I'm trying. I'm going right there. Let's see. Oh, that's pretty close. All right, let's try another one. So you can call this DEF or FED or angle E. I think this is straight across. I'm going a little bit higher. That looks like it's bisected. Yeah. Oh, so close. Let's do one more. You drew it perfect. Oh, thank you. Thank you. All right, let's do another one. Let's see. All right, I'm going with that. Notice that these angles have to match as well. Beautiful. Look at my orange and their red. All right. Now we get to estimate an angle measure. It's the same thing like estimating the distance, but it's for geometry. So estimate this angle. Oh man, this is 90, right? If it's straight up and down, it's 90. That's 45. So it's between 45 and 90. I'm going 78 degrees. Let's see what it is. It was 75. Nice. Let's do a new one. They let us have the protractor? I don't know. So this is, so the angles, just so you know, we have acute, which is small. That's between 0. And then we have right, which is exactly 90. And we got obtuse. This one's obtuse, which is between 90 and 180. Then we have what's called reflex. Oh, sorry, we have straight before reflex. My bad. We have straight, which is just exactly a straight line. And we got reflex, which is between 180 and 360. Oh, sorry, straight and reflex. This is 90, this is 180. 120. Well, I'm going 116. Let's see how close that was. Oh, 133. Just try a new problem. This one's really close to 90. I'm going with 82. Let's see what it is. Oh, I hit 83 by accident. It was 80. Nice. Cool. So definitely practice with these. Oh, we get one more of these. I guess these are the harder ones. Because it's moved. Ooh, this looks like a 90. This looks like a 92-degree angle. That's what I'm going with. 98. This one looks like it's an 88-degree angle. It was 90. All right, cool. So hopefully this was interesting for you. Estimate, have fun, measure some lines, measure some angles, show how to round. Sweet. The next one's going to be comparing numbers, which I think is going to be another short one as we go through these. And remember, there's going to be quizzes that I make at the end of these, and at the end of one, there's a test. So have fun with it. Hopefully this was interesting for you. If it wasn't, don't worry. We'll learn. We'll get it all together. Enjoy.